Every year in Canada, nearly 2 million tons of plastic packaging waste is produced. While food consumption is a basic necessity in our lives, the overall sustainability issues and environmental impacts cannot be negated. These include the deterioration of ecosystems and buildup of landfills.
Here in Canada, we are fortunate to have such a beautiful environment all around us, yet this privilege comes with the responsibility of maintaining a sustainable and clean future. To do so, we must address the rapid growth of waste pollution. Food packaging waste in landfills breaks down extremely slowly due to high concentration of waste. This produces harmful greenhouse gases like carbon dioxide and methane.
The solution our team developed is a compostable food package alternative that not only replaces single-use plastics, but also functions as a household compost box once its primary use is complete. The box itself would be made of a biodegradable material like corn or mycelium-based plastics.
This would mean the whole compost box, once full, could be put in a compost-friendly environment. Key functions of this box is separated from the other compostable containers by the removable blade mechanism and air ventilation system. The blade mechanism is a series of blades which are manually rotated to grind up the compost waste and create a more optimal compostable matter.
The whole mechanism can be simply installed in the box once no longer used for food storage and removed once full of compost. When the blades are not installed, the box still fully functions as a food packaging container. For composting, a consistent oxygen supply is required. This is why we designed air vents to allow constant movement of air in and out of the box.
This does raise one problem. The odor produced by compost isn't extremely pleasant. To counteract this, we designed a compartment near the vent in which odor neutralizing agent can be placed. Now that we know what our solution is, let's walk through the factors and processes which led us there.
Our team set out with the goal of designing a solution to reduce the amount of food packaging waste produced. We started this process by in-depthly analyzing the problem and creating a set of design requirements and evaluation criteria on which we base our design.
We determined that the design requirements would include our product meeting food safety standards, being made of biodegradable materials, being durable and safe for transportation, being user-friendly and shelf-ready, and being affordable to produce in mass quantities.
We have identified our investors as one of our primary stakeholders, and they expect that our proposed solution demonstrates a clear positive impact on the environment. Our design is purposefully curated to increase the amount of non-biodegradable packaging material that can be replaced with compostable materials. Larger elements of food packaging avoid the use of compostable materials since they are too flimsy for transport or they biodegrade too slowly. The integrated blade mechanism of this compost box allows for compostable materials to be used in larger scale food manufacturing. These manufacturers benefit from the broadening of available material choice, as the blade is able to shred through the thicker compostable materials, alongside removing plastic and cardboard forms of packaging from landfills. A clear understanding of our design requirements, we moved into the ideation phase, where we began with a brainstorming process, leading into a C-sketch activity. Following that, we did a gallery method where we combined all of our potential ideas.
We left the ideation phase and arrived at screening with 6 potential solutions. Through the use of weighted decision matrices and team collaboration, we scored and ranked each potential solution. We decided on the solution that we were going to take into the prototyping phase, that being our food compost box.
Our main challenge in the prototyping phase was that compostable materials were hard to access and difficult to work with. With our limited resources and time, we couldn't create a fully biodegradable prototype. Despite this, we made a total of 3 prototypes, the first being a low-fidelity physical fiberboard box with the purpose of giving us a visual idea of the geometry and general functions of the box while creating a baseline on which we can iterate. Our second solution was an in-depth virtual model of the removable blade mechanism, and our final prototype was a CAD design that closely represented our final solution.
With the first prototype, we impact tested the durability of the box and the functionality of the rotary blade mechanism. This was followed by virtual tests of various blade designs, which involved changing the geometry of the blade before we ended on a rouleau-inspired triangular blade, which is the most efficient geometric shape for grinding the contents of a square box. A full simulation on CAD tested the sustainability of different materials, analyzing the position of the center of mass, and an interference test across the blade mechanism.
It is imperative to complete a cost-benefit analysis before moving forward towards implementation of the solution. The prototypes lead to using cost-effective materials to make the box, leading to a low manufacturing cost. Additionally, manufacturers can make their product packaging out of compostable materials, saving money on environmental taxes. Therefore, the benefits of the solution significantly outweigh the potential downfalls of the implementation.
The limitations involve the amount of possible torque generated by the user while grinding the compostable material. A user would realistically be able to turn the blade mechanism between 40 and 60 rotations per minute. Future iterations would look to automate the blade system, which result in upwards of 300 to 500 rotations per minute. However, the stainless steel blade would incur noticeable wear at this level, leading to a change in material and an overall increase in price per unit.
In conclusion, the current iteration of our solution will pave the way forward for the food packaging industry to convert to sustainable material choices, leading to an overall completion of our set out objective of reducing plastic packaging waste.